Hey everybody, so one more binary search tree question. And why not? These are the hot interview questions. So let's get into it. So in this, we have given a number n and we have to tell how many unique binary search trees we can make that are valid. So for example, in the question statement also, they have given the input 3. For 3, we have 3 nodes 1, 2 and 3. So we can make these 5 structures out of these 3 nodes. So let's see. If n is equal to 2, we will have root 1 and 2. So what we have done is we have either fixed the value 2 and give it a child 1 or fix the value 1 and give it the child 2. So we got total number as 2. If the n is 1, we will have only one node. So the total number of unique structures will be 1. Let's see. When we have n is equal to 3, our roots are 1, 2 and 3. So let's fix 1 as our root. So we got 2 and 3. So we have to make possible combinations of 2 and 3 and that will be the total number of unique structures we can make. So we have seen previously that for 2 nodes we have 2 unique structures. So we can easily say if we are fixing 1, we will have 2 unique structures. If we are fixing 2, we have 1 on the left side and 3 on the right side. We can't really change their positions to get a valid BST. So we will have only one possibility. Then if we are fixing 3, then again we have 1 and 2 on its left side. So we can make different combinations out of 1 and 2. So for 2 nodes we have 2 combinations. So in this case also we will got 2 combinations. So for n is equal to 3, total combinations that we got are 2 plus 2 plus 1, that are 5 combinations. So let's see, for n is equal to 4, the roots are 1, 2, 3 and 4. So if we are fixing 1, we got 2, 3 and 4. So we can make as many combinations for valid BST as we can make for 2, 3 and 4. We have seen previously that for 3 roots we can make 5 combinations. So we got an answer 5. Then if we are fixing 2, then 1 also got fixed because it is the only possibility on the left side. But on the right side we have got 3 and 4. So we can make 2 combinations. If we fix 3, we will got 1 and 2 on the left side. So 2 combinations and 4 that is fixed on the right side. So if we fix 4, we have to find possible combinations of 1, 2 and 3 and that will be 5. So the total combinations that we will get for n is equal to 4 will be 5 plus 2 plus 5 plus 2 and that's 14. So let's see. If we see for n is equal to 5, so we will fix 1 and we have to make combinations of 4. So 14. When we will fix 2, we have to make combinations of 3. So 5. When we fix 3, we will got combinations of 2 and 2 on both the sides. So the possible combinations can be 4. So we will add 4. Then we fix 4 and we will have to make combinations of 3. So we will add 5. And then we fix 5. So we have to make possible combinations of 1, 2, 3 and 4. So we will add 14. So that's how for n is equal to 5, the total combinations can be 42. So we got the idea. So let's implement it. So simply making a function numTree and giving it a vector with one size larger because I am starting from 0. When the value is 0 means 0 nodes. So it is null. So the null tree we are giving 1. When we have one node, that means it is one unique tree having one node. So the value 1. So iterating over the loop, we have got the value of t0 and t1. So I am starting I from 2 and for each value we are finding the value of ti and finally returning the value that we are asked for, that is number of nodes we have given. Our j is going from 0 to I, so it is fixing all the value as node one by one and then adding it in ti. So I hope this is clear. This was really fun question and I hope these illustrations help you understand it. If it helped you, give it a like. And thanks for watching. I will see you guys in the next one.